Hello everyone, good afternoon. Dear authors and invited guests, welcome to technical session 9F. Myself, Tanish Virmani, and this session would be moderated by me. On behalf of Global Knowledge Research Foundation and GR Scholastic LLP, it is my great pleasure to welcome you all to the 10th International Conference on Information and Communication Technology for Competitive Strategies ICTCS 2025, Jaipur, India. The 10th editions of the conference is being organized in a hybrid mode. The physical event was held yesterday in Jaipur, and the virtual event is being held through Zoom on 16th and 17th December. I hope you will all enjoy the enjoyable, knowledgeable and interactive sessions throughout the day. In this session, we have 10 presentations. Each presenter will be given 10 minutes for the presentation and 2 minutes for the question answer. After 9 minutes, I will raise a gentle reminder for the same. There is another request to all the participants that you stay connected with us till the closing remarks. If you have any query or update, then you can write to me in the chat box. Just before we start the session, I need to give you the introduction for our chairperson. Dr. E. Ravi Kumar is an associate professor at Vardhaman College of Engineering, Telangana. With over 20 years of extensive academic and research experience, his expertise spans cloud computing security and the Internet of Things. Dr. Kumar is dedicated to advancing technological innovation, mentoring students, and contributing to cutting edge research that addresses emerging challenges in modern computing system. Yeah. So now we will start. If there is, sir. Yeah. Now we'll start with the papers.
Yeah,
First,
Tanish, you can go ahead. Good morning,
yeah,
everyone.
sorry, sir, if you are there, we'd love to hear you.
Yeah. Hi, good afternoon, everyone, all the participants. I wish all the best and present your papers without any hesitation and all. Just give the proper funda that you want to convey in your paper rather than going with the complete things about your paper because we have already gone through your abstracts and all. So you want to know about the technicality and the work that you have done in the paper. All the best for every participant and all the best for your team also, Tanish.
Thank you, sir. Now we will start with the first author, Sheetal Tana, for the paper title, A Predictive Strategy for Spoofing Mitigation in NavIC.
Hello, good afternoon.
Good
Am I
afternoon.
audible, sir?
Yes, you're audible. You can
Okay,
start.
thank you. So now I'm sharing my presentation. Hello. Is my
Yes, ma'am, it
screen
is
visible,
visible.
sir?
Yes, ma'am.
Okay. Thank you, everyone. Myself, Sheetal Tanna from SVNIT Surat. I am pursuing PhD under the guidance of Dr. Shweta Shah. She is Associate Professor and Dean SW over there. Now, today's my topic is a predictive strategy for spoofing mitigation in Navic. Actually, my research topic is based on this only. So, I would start with the awesome words that in warfare based on deception, attack him wherever he is unprepared and appear where you are unexpected. So, spoofing is like that only. Whenever the spoofer transmits the fake signal to the GNSS receiver, the victim receiver may spoofed by computing the wrong PVT, and so that we cannot rely on these spoofed receivers. So today's table of content is like introduction. Then I'll start with the vulnerability assessment in Navic, possible spoofing detection strategies. Then we will go ahead with the parametric evaluation, key findings, and then conclusion with the futures work. So first of all, I would like with the Okay, so this is the motivation why we are going with the Navic spoofing and its countermeasure that we already had many news about the GPS spoofing and due to which we may have many disadvantages and unhappening what that should not be happened. And even after the 2023, like our Prime Minister Narendra Modi has announced that all the manned and unmanned automobiles should be equipped with the NAVIC. So our concern is how to make our NAVIC system more secure against the intentional interference like jamming and spoofing. So the growing threat of GNSS spoofing and its consequences led us to build our own NAVIC system more secure against the intentional interference. Next is these are the contribution we started with knowing the spoofing, then how to create the spoofing scenario, how to analyze the parameters which are highly affected by the spoofing attack, and then we build the spoofing detection technique so that we can go ahead with the countermeasure. So these are the objectives. Like we will start with some NAVIC signal simulation. Then we study the possible detection techniques and how to perform the parametric evaluations that are affected by the spoofing. And then we compare them with the authentic signals. And we have also validated our results with the GPS spoofing framework so that we can have a strong validation point why we have selected this particular detection strategy, which is nothing but the predictive strategy. So this is the spoofing attack. Now you might be knowing that spoofing is nothing but actually unauthenticated activity. That is, it transmits the fake GNSS signal to the victim receiver that mimic actual signals. Now, due to the high power of this spoofing signal, the victim receiver may get spoofed, and so that we can get a wrong PVT, that is position, velocity, and time. Now these are the some papers that we have referred. Other parameters like they are affected by the spoofing are signal power, C by N0, time of arrival, direction of arrival, pseudo range, carrier phase, clock bias, and these are the papers they have highlighted that these are the parameters which are highly affected. Other non-parametric detection techniques are correlation, peak monitoring, antenna array, cryptography. All these are there, but they are highly computationally complex and they may require additional hardware to be attached to the GNSS receiver. So many times in many applications, like where they are using the low cost receivers, they might not use this type of techniques in which they have to go with the higher complexity. Other spoofing mitigation techniques are vestigial signal detection, multi-antenna null steering that we all know, and the RAIM, that is receiver autonomous integrity monitoring. Other papers based on the Doppler frequency, because we are targeting to see the impact of spoofing on Doppler frequency and pseudo range. We have gone through many papers on which they have provided the insights to the Doppler frequency and how they are impacted. So these are the papers. They have taken Doppler frequency as alone as the parameter, or they may have combined it with the C by N0 or other parameters. So these all are the Doppler frequency based spoofing detection. The next is pseudo range variation based detection techniques, into which the pseudo range is also a powerful parameter onto which the spoofing impact can be assessed. And so these many papers have also mentioned the same thing for pseudo range. But we have also included in our research the azimuth and elevation of spoofed satellite, which is yet not found in the literature. So that is the main and the novel approach we have targeted in our research work, that along with the Doppler, pseudo range, and azimuth and elevation based detection technique, azimuth and elevation may not give only alone solution, but additional solution can be provided with this Doppler and pseudo range. So this is the intermediate spoofing attack scenario, into which spoofer manipulates the satellite position. They calculate fake pseudo range and range rate. They apply earth rotation rate and then compute Doppler. Depending on this manipulation, spoofer can transmit the fake signal. This all process is done in this software defined radio, and then it transmit the GPS like signal or NAVIC like signal to the victim receiver. So this is basically the spoofing attack scenario we have implemented, and this is the flow graph we have adopted in our system. So the same thing what we have mentioned in the figure, This is mentioned in form of a block diagram where the auxiliary part of spoofing is additionally attached to the transmission part, in which we are manipulating satellite position so that it is based on the reader user motion file. That is what the fact position we require, that we have to insert into our auxiliary part. Depending on that spoofing location, the simulation will be manipulating the satellite position, then calculate pseudo range, then Doppler and all. And based on that, carrier wave will get changed so that the Navig spoofing is generated. Now, this is the spoofing scenario we have created at our lab and nearby our institute. We have taken 3 spoofing locations near to SV90, approximately similar distance in a straight path that is shown in the figure aside. So all these 3 spoofing locations are 2 kilometers, 4 kilometers, 6 kilometers from the reference. We have chosen this distance so that because our Navig satellites are geostationary in nature, so that we can identify little change into the pseudo range and Doppler if we take around 2 kilometers of distance, because they are 36,000 kilometers away from the Earth. Now, these 3 spoofing locations we have selected in the Gaurav Path road of SVNIT, that L1, L2 and L3. Parameters we have observed are pseudo range, Doppler frequency variation, azimuth and elevation. And to identify the spoofing impact, we have taken the detection strategy as a statistical analysis. So these are the plots we have found by considering the true data and the spoofing data for 3 different locations. At that time, while doing the field work, we observed that there are 3 Navig satellites visible. Those are SV6, SV9 and SV10. So we have taken those satellites into the consideration, and we can find that how the fake pseudo range is different from the true pseudo range. You may find little change only, but their values are different. Their tendency may be similar. Now in below figure, you can find the same kind of behavior of GPS satellites, as the GPS satellites are in MEO orbits. So they are continuously moving in the orbit, so that their pseudo range is continuously varying. While in Navig, our satellites are in geostationary orbit, so that the pseudo range will be varying very little. But due to the spoofing, we may find that there is a vast difference between the pseudo range. Same way, these are the plots for the spoofed Doppler and the true Doppler for 3 different locations. In Doppler, we may have the random behavior of the Doppler over the time, whereas in spoofing Doppler, we can find that they have some synthetic and the structured kind of tendency. They have continuous or maybe a ramp size or a step size, like that. So this make wider change into these parameters. The same way we have observed in the GPS also. So these are the computations we have made for the GPS and Navig data for spoofed Doppler and the true Doppler. We can find here that the standard deviation for the spoofed Doppler is very little. It is 0.0 in terms of that, very small. While in case of true Doppler, it is little bigger. So that shows that the true Doppler is it is like it is varying continuously and it is random in nature, while spoofed Doppler is very small and it is almost constant. Same way we can find for the GPS. Other than
Excuse me,
that,
ma'am.
yes.
Ma'am, this is just a dental reminder that the presentation time is up.
Yeah. So this is the last slide only. So these are the sky plots. We have found there are little changes in the sky plots also. So these are the values we have found for spoofed and true azimuth and elevation angles for different locations. So the conclusion is there are many applications which are based on the Navig only, and Navig security is the key objective. So it highlights that the pseudo range, Doppler shift and spoofed satellite position, they are critical features and we have to analyze them under the spoofing scenario, and they give us the predictive strategy, because Doppler and pseudo range are calculated before the PVT. So they give us the early detection, which is very, very important in getting the spoofing and its countermeasure. So the proposed framework is particularly crucial for Navig enabled UAVs, and they provide us it is also validated by implementing the GPS spoofing. So the other future work is we can go ahead with the real-time implementation, because this was the simulated, and then other detection strategies can also be implemented based on hypothesis testing and all, and we can go ahead with the real-time simulation also. So thank you so much. These are the references we have gone through. Thank you. Thank you so much.
Sir, if you have any questions for the presenter.
Yeah, Sheetal, the
Yes, sir.
good thing is you have done the work in real time. That's the nice thing in conferences point of view, because most of the people right now working on the existing data structures. My
Thank you,
query
sir.
is, you have used simulation, right, for data assessment
Yes,
of the
yes,
both the
sir.
parameters point of view.
Yes, sir.
Yes.
Yes, sir.
Yeah. So that simulation, with probably if I'm not wrong, you have gone through the MATLAB.
Sir, actually, we have tried to implement the Navic simulator taking the reference of GPS SDR sim, that is GPS simulator,
Okay.
and so that our simulation is also on C language.
C language. Okay.
Yes, sir.
So simulation completely have been done by you people, or you have taken any
Sir,
pre-and
our
from the.
team is still working on that, because
Okay.
Navic frame structure is completely different than the GPS. There are little queries that we have to yet solve. But during the simulation, what we have found that how this pseudo range and Doppler gets changed by inserting the spoofing location in the simulation, and based on that, we have done these simulations.
Okay. Actually, I thought of asking that one. What are the observation that you have done? Anyhow, good. Thank you. Sita.
Yes, thank you so much. Thank you.
Nice.
I would like to call the next author, Suvarna Kanakareddy, for the paper title AI-driven predictive model to prevent and control chronic heart disease.
Yes, sir. I'll connect, sir. I'll share my
Please.
slide, sir.
Sure.
Sir, is my slide visible, sir?
Yes, ma'am, it's visible.
Shall I start, sir?
Yes, please.
Good afternoon, sir. Myself, Suvarna Kanakareddy. My paper title is Predictive Analytics to Prevent and Control Chronic Disease Using AI Techniques. My paper ID is 818. Agenda of my presentation is, this is one of the research carried out for the postgraduate students. Here, basically, we have taken a data set, heart disease data set we have taken, and that we have tried for analyzing. Agenda of my presentation goes like this: introduction about uh, the research work, and then problem statement, objectives, and then proposed work, and data set description, implementation, and result analysis. Basically, to provide the introduction about the heart disease. Nowadays, everyone is caring about their health, and then here one of the organ we have considered here for analysis is about the heart disease. Mainly here, across the globe, as per the World Health Organization, every year 17.9 to 19.8 million people, they are suffering with the heart diseases. So here, to identify the early risk factors which causes for such type of diseases is the major cause for the doctors, as well as for even in the every user should know how exactly which are the risk factors which are affecting towards the disease. Here basically in this work we have tried for using the machine learning solution for early disease prediction and identifying the risk factors which causes the chronic heart disease. And here, to provide the problem statement of this work, actually here to build a predictive model for identifying the risk factors of chronic heart disease by using machine learning techniques. Here we have tried with various machine learning techniques like convolutional neural network, and then different architectures we have tried for analyzing the behavior of the patient health records. So objective of the work goes like this. Here to develop a predictive model using AI techniques to identify the risk factors uh, for the chronic heart disease. And here the main focus will be on analyzing the image uh, data such as ECG images. And here we have tried for applying the machine learning techniques to predict the uh, patient health condition, and the system accuracy, model accuracy we have evaluated through accuracy. So the proposed system initially here we have collected the data from the UCI repository, and that we have initially pre-processed, and after pre-processing, we have applied the machine learning algorithms for training the data set using CNN, and then VGG16 and VGG19 models we have applied. And we have validated the training accuracy and then test accuracy. And finally, we have chosen the model for implementation. This is how the workflow goes for this proposed work. And here the parameter tuning we have tuned for the optimizers, and then for the batch size, and then the learning rate. These parameters we have tuned. The data set actually includes totally 929 images. The data size was very small, but even though we have tried for augmenting this data set, and here 742 images we have considered for training, and then 91 images we have considered for testing. These images are of ECG images, electrocardiogram images. Here, four sub folders were there in this image data set. Some of the image samples are one sample consists of ECG of myocardial infarction patient data, and other subclass consists of abnormal heartbeats, and third subclass consists of the ECG of the patient having history of myocardial infraction, and fourth subclass is of ECG of the normal person. So here these image data we have analyzed, and we have trained our model for predicting the performance of whether the patient health condition is normal or abnormal, or is there any infraction, or the blood flow is appropriate, or blood flow is less. So those kinds of analysis we have tried. So here by applying CNN, we have run the model for 30 epochs, and then we got the training accuracy. Less accuracy we got because the image size was less, 54.57, and training loss was 10.76, and validation loss is about 4.10, and test accuracy we achieved here is about 52.01. This is about the performance graph of the accuracy of the CNN model. Next, we have tried for improving by using VGG16 model, and we achieved the training accuracy of, there is an improvement compared to the previous model, 72.74%, and test accuracy of 67.27%. So this is about the training accuracy and validation accuracy graph. And to improve further, still we have tried for improving the performance of the model by applying VGG19 model. We achieved better result compared to the previous two models. Here we obtained a training accuracy of 75.80, and then loss of 9 point loss was decreased, and train validation loss of 9.06, and even testing accuracy has been improved, test accuracy of 71.83%. And this is about the VGG19 model accuracy. Among three models, VGG19 model has performed better. To compare all the three models among CNN, VGG16, and VGG19, VGG19 has performed better. This is about the analysis of the ECG data which we have collected from the UCI repository. And to conclude about this work, uh, mainly the predictive analytics which we are applying by using the AI solution will prevent the patients health, and even it helps the doctors for further analysis also. Uh, this is how I can say that AI and machine learning plays an important role nowadays in the healthcare. And here we obtained the performance of the different models and the comparison about the three models. What we have tried is to analyze the uh, patient data of four different classes we have analyzed. And among the three, VGG19 has performed better with the advancement in the predictive analytics and the uh, advanced deep learning techniques will help the doctors as well as for the patients also to monitor their health conditions and to know about the status of their health conditions. So early prediction can be done, as well as to provide the better treatment also. Uh, it helps. So this is how I can say that nowadays in healthcare AI plays a major role. And here we have referred some of the papers. The various authors have tried different models, and some they have tried with the clinical data set also. So this is about the presentation, uh, overall presentation. So with this, I can say that machine learning plays an important role. So thank you very much, sir.
Hello.
Sir,
Yeah,
sir.
Sona,
Yes, sir. Yes, sir.
you have used three different models on the same
Yes, sir.
data set, right?
Yes, sir. Same data set, sir. Same
Uh,
data set.
Everything is good, but for as per your slides, you said in each model point of view, the epochs that you are using is 30, 40, and 60.
Yes, sir. The model has saturated for that particular number of epochs with respect to that model. That's why
Oh,
there is a variation in the number of epochs, sir.
okay. But as per the ML criteria, even a slight change in the dataset parameters might impact the accuracy, right?
Yes, sir. Yes, sir.
So,
Here we have tried for improving the loss, sir. Whatever loss is there, we have tried for improving the loss, and then to improve the accuracy also.
okay.
To get the
So,
better accuracy, we tried.
okay, anyhow. Right. Thank you.
Okay, sir. Okay. Thank you very much.
Thank you so much. We'll start with the next author, J. Sebastian Nixon, for the paper title "An Adapted Machine Learning Framework for Detection and Mitigation of Rogue Access Points in WLAN." So, do we have you?
So are you able to, sir, is it audible?
Yes, you are audible, sir.
Can you look into my screen, sir?
Yes, I'll stop sharing. You can start now.
Yeah, sir. Good afternoon, sir. And our research topic is an adaptive machine learning framework for detection and mitigation of rogue access points in.
Excuse me, sir. I'm unable to see your screen, sir.
You're unable to see.
Yeah.
1 minute, sir. What happened?
Still not visible.
So 1 second, sir. No, I don't know what happened. Is it okay, sir?
No, sir. It's not visible till. Yeah, now it's visible.
Oh, is it okay?
Yes, sir. I'm able to. Yeah. Now you can start.
Yes, sir. My topic is an adaptive machine learning framework for detection and mitigation of rogue access points, sir. It's AI-based WLAN security, and my ID number is 888, sir. WLANs are widely used due to flexibility and vulnerability to cyber attacks. Rogue access points pose serious threats, sir. And Wi-Fi networks are widely used in enterprise environments, providing seamless connectivity. And rogue access points pose a severe security risk by allowing attackers to intercept sensitive data and launch cyber attacks. In this paper, we proposed an AI-based technique for auto-configure authorized APs clients detect and prevent rogue access points using machine learning approach to secure the wireless networks from unauthorized access. We propose to use multiple ML algorithms for RAB detection, such as support vector machines used for effectively classifies high dimensional data, random forest to robust against overfitting, and it is suitable for future important analysis, and artificial neural networks for identifying complex patterns in network behavior. By implementing our proposed framework, we can secure WLAN for several cyber attacks. This is the picture, sir. Architecture of rogue access points, sir. What are the types of rogue access points? Are compromised access points, unauthorized access points, improperly configured access points, and phishing access points. What is rogue access point? It is unauthorized access point used for phishing, difficult to detect using traditional methods. It is an compromised APIs. Compromised APIs are set up by intruders who crack the security. Once the attacker gains access to credentials, they can establish multiple rogue APIs, access points. This type of attacks typically carried out by insiders. What are unauthorized APIs? Unauthorized APIs mimic legitimate access points but are installed without the permission of the network server within a secured environment. Improperly configured access points, improperly configured access points result from configuration errors, a lack of knowledge in choosing appropriate encryption schemes, and authentication algorithms are false in the access point setup, which can cause them to function as rogue access points. Phishing access points deceive users by pretending to be legitimate access points in order to capture sensitive informations. Wi-Fi access points allow devices to wirelessly connect the LANs and internet. However, rogue access points set up within a network area without approval present serious cybersecurity threats. These rogue access points can enable man-in-the-middle attacks or be exploited in phishing schemes. Since setting up rogue access points is quite simple and many public access points operate as open networks, it becomes essential to establish strong detection mechanisms to identify and prevent rogue access points. What are the limitations of existing methods? Manual auditing is not scalable. Rule-based IDs cause false positives. MAC and SSID spoofing possible. To monitor the network, RF future important analysis and SVM high dimensional data classifications and learning complex patterns in network behavior. If abnormal activity is found, then terminate, else go to the label 1, we need to end. See, we have in this model, no, we have first we need to start the thing, and next we need to register the thing in the APIs client, okay, and connect for internet. And AI enabled model, we are going to use SVM, RF, and ANNS. And if registered, we are going to check whether it is registered in the MAC. If it is registered, in the sense we are going to allow. If it is not registered, we are going to terminate that access points. The AI enabled model with the authorized APIs. These are the scenarios we are considered. What are the results and discussion? There are several ML algorithms in detecting rogue access points in the proposed AI-based machine learning framework. They are the random forest with its strength against overfitting and the analysis of future importance. Support vector machines that are effective in high dimensional classification and artificial neural networks that are capable of capturing and learning complex patterns in network behavior. We train and test the ML-based RAB detection model using real-world network traffic datasets or Kaggle datasets. Finally, we will implement in the network control server to detect and prevent the rogue access points and clients. As shown in the scenario 3, this model will allow only the authorized registers and APIs and clients. In case any RAPs or unauthorized clients try to connect in the network, means the model will detect and terminate the unauthorized devices as shown in the flowchart. By implementing our proposed technique, we can secure the WLAN from several cyber attacks. This is the scenario 3, attempts of unauthorized APIs, the network with the authorized APIs, clients and unauthorized actors. Here we need to register. First, we need to start the process. Next, we need to register the authorized APIs, clients, MAC, address with the AI model. Then we need to case the authorized APIs and client is to be robust network. AI-enabled model we are using. If any abnormal activities are happened, it will be terminated, or else we are going to allow. What is the conclusion of the future work? In this paper, we demonstrate the effectiveness of AI-based techniques to auto-configure only the authorized APIs, hide the SSIDs, allow only the authorized clients, also detect and prevent rogue access points, unauthorized clients. Since this model uses multiple machine learning algorithms to find different RAPs activities, this mechanism can provide high security for the wireless networks. In this paper, we propose the AI-enabled security mechanism. In future work, we can implement it in the real time.
Excuse me, sir.
Yes, sir.
So this is just a gentle reminder that 9 minutes of the presentation are up.
Okay. Thank you, sir. Hello.
Yes, sir.
Please go ahead.
Okay, sir. Now, machine learning algorithm. What are the machine learning algorithm we are used is random forest feature importance and SVM high dimensional classification, ANN complex behavior detections. Proposed algorithm is registered MAC addresses, monitor the network continuously and detect the anomalies, terminate the unauthorized access. What are the scenarios we need to be explained is authorized AP configuration, authorized client access, and detection of unauthorized access points. Now, what are the final discussion is improved detection accuracy, reduced false positives, and strong protection against RAPs. AI-based system enhances WLAN security. Multiple ML models improve the detection, effective against cyber attacks. The future work is real-time deployment. We are going to install this and large-scale enterprise implementations. Thank you, sir. Hello.
So you said you have used around SVM, random forest, and ANN all together, right?
Yes, sir.
So have you checked for the model how it works and what is its result set that you got from the existing data set, whatever you have used it from the Kaggle,
Yes,
right?
sir. Recently, we have checked in the small organization. Okay, and we have got some positiveness through that.
Okay, it would be better if you can keep those sort of stats also, then we can
Sure,
get
sir.
better
Sure,
picture.
sir.
Okay, right. Thank you.
Thank you, sir. Thank you, sir.
I would like to call the next author, Syed Nawaz, for the paper title, Audio Deepfake Detection Using Deep Learning Methods, a Survey.
Yeah, good afternoon, sir. Am I audible?
Yes, you're audible. You can start screen sharing.
Yeah, sure, sir. Yeah, is my screen visible, sir?
Yes, it's visible.
Just a minute, sir. Yeah, good afternoon, respected chairs, judges, and my fellow researchers. I am Syed Nawaz from the Department of Information Science and Engineering, Vidyavardhaka College of Engineering, Mysuru. Today, I will be presenting our survey paper titled Audio Deepfake Detection Using Deep Learning Methods. And these are all the things I'm gonna cover with this presentation, which includes abstract, introduction, the generic block diagram, challenges, review, data sets, the comparative study, and conclusion, future scope with some references. With the rapid rise of AI-generated voices through text-to-speech and voice conversion, audio defects have become a serious threat, which enables fraud, misinformations, impersonations. So this survey systematically analyzes how deep learning models are being used to detect such synthetic audio, the dataset used, the key challenges, and the open resource directions. And coming up for the abstract part, we review recent deep learning based approaches for audio deepfake detections, because the traditional handcrafted features like MFCCs, which means male frequency substral coefficients, which are the numerical feature of the audio, are no longer sufficient against modern TTS and voice control systems. So, and deep learning models such as CNNs, raw waveform models, and transformers can capture the subtle artifacts which are present in synthetic speech. And not only the models, along with the model architecture, we also analyze the benchmark datasets and identifying the key challenges like poor generalizations and adversarial vulnerability, which I'm going to discuss in the further slides. And coming up for the introduction, this basically emphasizes why deepfake audio is dangerous and why the old methods fail or where they lack, and why the deep learning is needed. Deepfake audio today can convincingly mimic real human voices, which leads to threats, which I said, like phishing and identity impersonations, etc. And earlier deepfake detection systems was majorly relied on handcrafted features, so the system was getting failed. And however, the existing systems also struggle with scalability, dataset variability, and other methods. And we also look at the different models which they used for defect detection. And this is the generic block diagram of an audio deepfake detection, which explains how the audio deepfake detection using deep learning methods work, where basically the first step comes as data collection, where the raw audio is gathered from source such as phone calls or audio calls or studio recordings, which is splitted into training and testing sets. And then we have the next step, that is pre-processing and augmentation. Here, the noises are get removed, silence is trimmed, clips are like standardized, and augmentations, which augment pitch, tone, addition of effects, etc. And then the next step comes is feature extraction, where we extract three features basically: spectral features, prosodic, and voice quality features. Spectral is nothing but the male spectrograms, and prosodic features is nothing but the rhythm and the tone. And normally the voice quality features is like the quality of voice, the natural voice or AI generated. And then these are deep learning models like CNN, RNN, or LSTMs are trained on this, so they can learn patterns and artifacts from this. And then the trained model assigns some detection score, which determine whether the input audio is fake or real. That comes on the classification part. And then the final step will be model refinement, where the model gets refined by using the feedback. This is about the generic block diagram. And coming up for the research gaps, this is the important part which comes in, where first of all, lack of generalization, which means overfitting, where the current models perform well on in-domain datasets, but they fail on unseen attacks. And by our review, we reviewed in the paper 8 has mentioned, where they achieved some 97 to 98% of accuracy on the in-domain dataset, but which the performance got dropped during dataset evaluation with different unseen attacks. And next is adversarial vulnerability, where deepfake detectors often rely on subtle acoustic cues, making them vulnerable to small, imperceptible audios. And that has been referred by paper 5, where they demonstrated how the model got misled by minor frequency changes. And then comes the identity leakage. This is the major problem, where many models unintentionally learn speaker's identity instead of artifacts, which reduces the reliability. And in the paper 5, they have been addressed this issue by using ADMs, where ADM stands for artifact detection models, by suppressing the speaker's identity. And another challenge can be high computational cost, because the deep architecture models like generative adversarial networks and the transformer-based models demand high processing. That can be an issue. And the another thing is dataset limitations, where many of the dataset lacks the real-time audios or some variations. That can be another issue. And poor adaptability to new deepfake voices, because all the existing, because this deepfake detection is not stable. It's getting better by day by day, because AI is getting trending. So these are the major challenges we have faced. And coming up for our literature overview, to clearly understand the existing research, we categorize audio deepfake detection methods into 3 major groups. That is spectral front ends, which includes CNN hybrid models, where audio signals are converted into time frequency representations such as male spectrograms and etc. to distinguish the synthetic speech and real speech. And another group comes under has end-to-end raw waveforms and transformer-based models, where the models like RawNet and RawNet Lite, they capture fine-grained temporal and phase level informations from the raw audio. They don't convert it for spectrograms or something. And then the third category, this category is not about the models. These are the which focus on new architectures, on improving robustness and trustworthiness, like augmentations, adversarial training, attention-based explainability to improve robustness, and the generalization, which I talked about during my research gap. These are some of the literature overview of the models which we have addressed. And yeah, coming up for the data set, but these are some of the data sets which we have found out. There is something called ASV spoof, that is automatic speaker verification, which has a longer series from 2015 to 2021, where we can see the stats of it in the table which I have represented, where they split it. Training, development is nothing but testing, and evaluation is nothing but testing, and development is nothing but validation. And these are the numbers of speaker and the utterances, which are split into real and bona fide, where we have ASV spoof 2019 dataset, fake or real dataset, in the wild datasets, and ASV spoof 2021 datasets, which further has classified into logical access attacks, physical access attacks, deepfake attacks. And this is the comparative study, which basically covers or shows the trade-offs between the approaches used, the models, the datasets, and the metrics, and what they have highlighted on that. Yeah, for example, to take up some papers, let's take the first paper, that is in the year 2023, where their approach was CNN on spectrograms, where they used the convolution neural networks model, and they achieved some accuracy of 85% and accuracy under curve of 0.87. And these are all the other papers which we referred to take up the trade-offs. And coming up for the conclusion and the future scope, to conclude, this survey, which reviewed the recent deep learning approaches from audio deepfake detection, highlights advances in CNN's raw waveform models and transformer-based architectures. While we are not only focusing on the detection accuracy, because detection accuracy has improved by day, but the challenges remain in generalization, robustness, and interpretability. So the future research should focus on lightweight models for real-time deployment, multi-representation learning, and some artifacts-focused detection which suppresses the speaker's identity and explainable AI frameworks. So addressing these challenges is essential to build a reliable defense against the rapidly evolving deepfake technologies. And these are all the references. Totally, we have referred around 21 papers. Basically, some of them for the accuracy and metrics thing, and some of to understand how it works. Yeah, That's all. Thank you. I'm happy to take any questions.
Yeah, Nawaz.
Yes.
Yeah, good thing that you have gone through the plenty of papers for this literature survey point of view, and the
Yeah. Thank you.
topic also very good. Thing is, it would be better if you can focus on those reviews point of view. What is the actual accuracies they have gone with which type of algorithm, so that you can later propose if there is any. In one slide, you have mentioned 3 or 4, right? Accuracy parts.
Yeah, sir.
Yeah. Uh, but thing is, data sets. All those papers have same data sets. I'm sure.
Yeah, so all the means the above three papers were using the ASV spoof datasets.
Okay.
And the challenge lies is means we have some hybrid datasets, hybrid dataset also, and we are majorly focusing on 2021 dataset.
Okay. Okay. Right. Nice.
Yeah, because these are all the existing models.
Yeah, these are all right. Good. Thank you.
Yes. Yeah, thank you. Sir. Thank you for the opportunity.
I would like to call the next author, Omkar Sawant, for the paper title Design and Development of Customized Role-Based Access Control Mechanism for Learning Management System.
Good afternoon, sir. On behalf of Omkar, I'm going to present the paper. So,
Sure.
am I audible?
Yes, you are audible. You can screen share.
Thank you, sir. So, sir, is my screen visible?
Not right now.
So, just a second. Sir, now is it visible?
Yes, it's visible. You may start.
Sir, just a second. So, good afternoon, everyone. Today, I am pleased to present my research paper on. Sir, is it visible?
Yes, it is visible.
So, good afternoon, everyone. Today, I am pleased to present my research paper titled Design and Development Customized Role-Based Access Control Mechanism for Learning Management System. And my paper ID is 907. So, in this presentation, I will briefly discuss about introduction of learning management system, motivation and problem definition, system design, system implementation, result analysis, conclusion, future scope, and some literature surveys and key insights and success strategies. So, learning management system. Learning management system play a very important role in modern education. They help institutions manage courses, student, faculties, learning material, and assessment in a digital way. One key issue in many elements platform is access control. Different users need different permission. Role-based access control ensures that each user can access only what is required for their role. The main objective of this project is to develop a customized LMS with a secure and a flexible role-based access for admins, faculty, and students. Further, many educational institutions currently use multiple disconnected systems. This causes confusion, data duplication, and insufficiency. There is a strong need of centralized digital platform that integrates all academic activities. Existing LMS platform often lack customizable access control and proper data security. Our proposed LMS addresses these issues by offering secure, role-based access and efficient academic data management. Here is the system design. The system design is developed using MERN stack, which includes MongoDB, Express.js, React, and Node.js. This architecture ensures scalability, performance, and flexibility. The three main user roles are defined as admin, faculty, and student. Each role has specific permissions, ensuring secure and controlled access to some system features. System implementation. On the client side, user-friendly dashboards are designed for all roles. The interface is simple and easy to use, even for non-technical users. On the server side, Node.js and Express.js handle backend operation, while the MongoDB manages the data. Strong security mechanisms such as authentication and session management are implemented to protect the user data. There is the result analysis. The faculty dashboard allows teachers to manage courses, monitor student performance, and analyze progress. The student dashboard provides access to courses, assignments, and performance tracking, which improves student engagement. The- And the admin dashboard enables user management, system monitoring, and institutional performance analysis. Overall, the system improves efficiency, security, and user experience. Conclusion. In conclusion, the proposed LMS successfully integrates academic process using customized role-based access control. It enhances the data security, user interaction, and system efficiency. For future enhancement, we may include AI-based personalized learning, cloud deployment for better scalability, and mobile application development for wider accessibility. Literature survey. Literature survey shows that modern LMS platform focus on customization and user engagement. However, challenges such as data privacy, ethical concern, and scalability still exist. Open source LMS platforms offer more flexibility and cost benefits compared to proprietary systems. And the last is key insight and success strategies. Role-based access control is essential for secure and efficient LMS implementation. Successful deployment requires a proper user training, continuous feedback, and a regular system improvement. Future LMS development may include advanced technologies like AI and blockchain to further improve the security and trust. Thank you for your time and attention. I would be happy to answer any questions.
Yeah, Pratik,
Yes, sir.
uh, what is the actual essence of your paper you want to convey in this LMS point of view?
Sir, our aim is to create an LMS which is
Hmm.
very student friendly and faculty friendly also. So that because
Uh,
in yes, sir.
yeah, if I'm not wrong, we have
Because
already plenty of LMS portals and systems available in the market, commercial versions as well as free versions, if I'm not wrong. Have you gone through any of those while your
yes, sir.
literature survey and all? Hmm.
Uh, according to me, there are Blackboard and Google Classroom are also on LMS platforms.
Hmm.
Other than that, there are more other LMS platforms. For this, we have gone through our own college platform also. We have gone through students for survey and feedbacks that problem on issues faced by students and also with the faculties. And for
Okay, how your LMS model that you are going to say that a bit differ or special or something which you can say plus point for your LMS model compared to the existing models like K12, whatever you said, Moodle or Google Classroom, Canvas, LMS, whatever you can call.
yes, sir. For our LMS, there are as we have gone through many college LMSs, college LMS, we have seen that there are different platforms for accessing the results, for filling the forms, and for payment of fees and all. Our LMS is trying to combine all this in a single platform where you can get the results as well as pay the fees and everything.
Okay. Anyhow, so my suggestion is when you go for the further any advancements are working on this, first of all, you try to differentiate that part, like what are the existing models are there or what are the pros and cons of those systems and what is the main essence of your model which you are developing or already developed and what it is going to provide with. So that that can give you a better picture about your concept or the work that you have already done are going to be. Okay? All the
Okay,
best.
sir. Thank you, sir.
Now I would like to call the next author, Rasika Revatkar, for the paper title Early Stage Colorectal Cancer Prediction Using Transfer Learning and Ensemble Techniques. Ma'am, do we have you? Rasika ma'am?
Hello.
If Rasika ma'am is not there, then we can continue with the next presentation. Prachi, for the paper title Harnessing Artificial Intelligence and Machine Learning for Precision
Yes,
Therapeutics, Parkinson Disease.
yes, sir.
Yes,
Wait, sir.
please start the screen share. Yeah.
Okay, sir. Am I audible, sir?
Ma'am, actually, um, after this, I'll call you to your name, ma'am.
Okay, okay.
Yeah. Prachi, ma'am, you could start.
So is my screen visible?
Yes, it is visible.
Okay. So good afternoon, one and all. Myself, Prachi from Graphic Hill University, and today I'm presenting my paper that is Harnessing Artificial Intelligence and Machine Learning for Precision Therapeutics in Parkinson's Disease. So this is the framework for the AI-driven precision therapeutics for the Parkinson disease. So the main problematic area with Parkinson's disease is it is a neurodegenerative disease which usually affects the aged individuals above 50 years of age, and in which in this disease usually the dopamine levels used to deteriorate with age. And this is the major drawback with the disease is that we cannot easily detect the disease at an early stage, so that we cannot also give the customized treatment to the patients also because of the late diagnosis or late detection of the disease. This disease is mainly manifested by the motor and the non-motor symptoms, and the motor symptoms are usually seen because of the deficiency of dopamine here only. Then the role of AI and ML in Parkinson's disease is AI ML has the interpretation of complex data sets and has accelerated the transformative change in precision medicine. The use of these technologies, by the use of these technologies, we can integrate different kind of informations we have by the labs also, by the
Excuse
genetic
me.
profiles.
Is your slides are moving?
No, sir.
No, I don't think so. Check it once.
Sorry,
Tanish,
sir.
Yes,
can you
sir.
check once Prachi's slides are moving up?
As far as I see, it's problem statement right now on 7th slide.
Yeah, check it once, Prachi. Is that right? Your problem statement slide is only you are presenting?
No, sir.
No,
No,
that's
sir. No,
what.
sir.
Something it is a different slides or some presentation, something. Sharing of things are changed, I think.
Yes,
It
sir.
might be someone else, I think.
Yes, sir. Yes, sir. It is someone else.
Actually, Rasika ma'am is sharing. Rasika ma'am, could you please stop sharing? Yeah. Prachi ma'am, now you could start. Rasika ma'am, I'll call you after this presentation.
So that's what I'm getting out. The presentation is
Yeah,
something
actually, I
different.
was able to see problem statement. Prachi ma'am, could you please share?
Yeah, Prachi ma'am, now you can share your screen, I think.
So the screen is visible.
Not right now. Prachi ma'am, could you start the screen?
So my wait, sir. So my screen has been stopped working. Can you give me 2 minutes?
Should I start another
Wait,
presentation right now?
no, sir. It's wait.
Okay. Yeah, now I see your screen.
Okay. So is it visible now?
Yeah, you're on
Is it
second.
visible now, sir?
Yes, it is visible.
Yes, please
Yeah.
go ahead.
Okay. So the role of AI in AI and ML in Parkinson's disease is as as I'm from the science background only, but we are collaborating with some engineering people only and working on this researching that with the help of AI and ML, the ML has made the interpretation of the complex dataset easier, and the genetic profiles with the use of different kind of information such as genetic profile, clinical evaluations, proteomic, metabolic symptoms, neuroimaging data, we can integrate all these information, and with the help of variable devices such as the real-time monitoring is also possible, and the machine learning methods will also help in the continuous monitoring of the disease, and it can detect the minute connections and the patterns and can permit even to capture the symptoms at a very early stage. Then the technology can also forecast the pattern of the ADME patterns, the absorption, metabolism, distribution pattern also, and can help the physician to manage the condition at a very previous stage and in a very customized way. Precision, that is why the manuscript is based on the precision therapeutics, that is so, and the AI ML has also led to the discovery of biomarkers, classification.
Hello.
Hello.
Please go ahead. Your voice I unmuted, I think, in between.
So the AI ML has revolutionized the typical PD management by forecasting a more proactive, personalized approach to control the disease. Then what are the current challenges in the PD disease treatment? First, the challenge is the variability in the treatment response, as every individual has a different genetic makeup. So the treatment response to each medication is different. Then there is a lack of personalized approach because, as I have already said, that there is a different genetic makeup and different metabolic profile also. So the response of each treatment is different in every individual. Then there is early detection limitation and challenges in the continuous disease monitoring also. So these are the challenges that we can overcome with the help of the AI and ML, and help for the for the precision therapeutics in the treatment of PD. So the role of AI in precision therapeutics is first one, the early detection and diagnosis by using the AI models, utilizing the multimodal data. Like these are some of the problematic area in PD, like the speech, the handwriting, gait analysis, neuroimaging. By integrating all the data, we can identify, or the clinicians can identify the prodromal PD disease at a very early stage. Then we can also provide, if it is diagnosed at a very early stage, we can provide the patients with the personalized treatment plans, and continuous disease monitoring and management will be possible in no or very few clinical trials. And a large amount of the data that is present in the databases can be converted to very useful information for the physicians or the clinicians, and allowing to customize the treatment plans. And then the optimizing advanced therapies. Predictive model provide a more efficient work style by reducing the frequency of unwanted events. And in the later stages of PD, usually we provide the DBS, deep brain stimulation to the patients. So we can predict the best possible placement of the electrodes in the brain region in the later stage of the Parkinson disease. Here also the AI ML can help. Then the machine learning applications in PD is predicting the disease progression. With the help of these ML algorithm, we can these models can be trained for long-term patient record to understand the patterns and accurately identify data by motor and cognitive deterioration trajectories, predicting disease progression, pattern, and stage. Computational forecasting can also identify patients who are at higher risk also, and progression at a very early stage. Biomarker discovery, one of the major disadvantage for the disease is there is no biomarkers available for the disease, so that we can detect the disease at an early stage. So with the help of the ML techniques, the early detection of PD with the discovery of new biomarkers is also possible by combining the multi-omics data with advanced imaging techniques. Then optimizing medication dosing, as the AI ML model can easily interpret the pharmacokinetic and dynamic profile of a drug, helping optimizing its dose, frequency of dosing, virtual twin engineering, the simulation models before testing all these models to the real life patients. We can we can also use these simulation methods, enabling testing the treatment therapies on computer systems first. Then the future directions and implication, integration of the multimodal data is the first future direction. Then the regulatory and ethical consideration, clinical implementation, cost effectiveness and accessibility, research and development. Then the advantage of early detection of PD when accompanied with multiple biomarkers lead to a better and timely treatment approach for the disease and providing a quality life to the patient. Predictive modeling reduces treatment and detection time and cost, whereas diagnosis and therapy without AI needs several tests and trial and error prescribing. And combining the technology and biomarkers improve the treatment approach and the output also. And so the conclusion is the AI ML technologies potentiate the transformation of PD management by allowing early diagnosis, a customized approach, and persistent scrutiny also. So with the amalgamation of AI ML, the disease detection can be at a very early stage and customized treatment can be made available to the patients. Thank you.
Yeah. Right. Thank you, Prachi. First and foremost thing, your concept title and the concept motto is good. Have you used any real-time data, or you have went with the existing any data set, Kaggle data set for your paper point of view?
So we are using the data sets only that are available online, but still now we have not used, but we are in future, we are planning to use the data available with the physicians only.
Okay, right. Right. Anyhow, good topic. Right.
Thank you.
Yes, I would like to call Rasika Revatkar ma'am for the paper title Early Stage Colorectal Cancer Prediction Using Transfer Learning and Ensemble Techniques.
Yes, sir.
Yes, ma'am, you can start sharing.
Yes, sir. Is it visible, sir?
Yes, ma'am, it is visible. You may start.
Okay. A very good afternoon to one and all present in this online conference session. I, Rasika Manoj Revatkar, PhD scholar of YCC, that is Yashwantrao Chauhan College of Engineering, Nagpur, under the guidance of Dr. A.R. Bhagat Patil. My presentation topic is early stage colorectal cancer prediction using transfer learning and ensemble techniques. Now see, these are my contents. So let's move to the introduction. So colorectal cancer starts in the colon or the rectal. So these are the cancer are also called as the colon cancer and the rectal cancer. Am I visible, na sir? My PPT is visible?
Yes, ma'am. You continue.
Okay. Colon cancer and the rectal cancer are the group together because they are having a many common features. So cancer starts when the cells in the body will start grow out of control. So most of the colorectal cancer is the third most common cancer diagnosed in the people who all over the globe. So early diagnosis of CRC, that is a very global health issue. So let's see how the colorectal cancer performs. Now see, this is our these are the four stages, four sections where the colorectal cancer performs. That is, this is the ascending colon, If the colon starts in this area is called as an ascending colon. If the colon or rectal cancer is affected in this area is called as an transverse colon. If the cancer happens in this section, that is called descending colon. And if the cancer is happened in this section is called the sigmoid colon. So these are the 4 sections where the colon cancer is happened. Now these are the stages of the colon cancer. So mainly the stages 0 to stage 4, the colon cancer grow rapidly inside our cells. So this is the at the stage 3 and 4. These are the extremely high level where are the it is a very risky to get the lives of the individuals. So we what is my aim? My aim is to identify the early stage of these colorectal cancer from stage 1, stage 0 to 2. So this area I have to focus is on in my study. So what are the risk factors of this colorectal cancer? First is the older age, inheritance syndromes, then family history of colon cancer, low fiber and high fat diet, not exercising regularly, diabetic patient, obesity, smoking, drinking alcohol, and radiation therapy for the cancer. So these are the risk factor where the colorectal cancer starts the starts grow in our body. Now these are the problem statement. So manual diagnosis is the time consuming and subjective. So that's why the early stage cancer cell are visible very similar like a normal cell. So need to fast, automated and accurate detection of system is very important. So now let's move to the objective. So my objective is to develop a model for the early stage colorectal cancer prediction. So according to the survey, it is found that the most of this colorectal cancer happened in the main, that is gender male. So to apply this transfer learning for the effective feature extraction, to use this kind of assemble technique for the higher accuracy and perform the evaluative medical accuracy matrices. So here I am using the data sets, that is a NCT-CRC, which is having a 100K data sets. The image categories are normal tissues, early stage cancer tissues, and some polyps, that is a precancerous tissue. So whenever your polyps, these are called the polyps. So polyps from stage 0 to stage 2, this is called the polyps, and this is the precancerous tissues. So these tissues are categorized into the again 9 classes. That is, these are the 9 classes I am using in my NCT-CRC data. So first I am performing the pre-processing steps. So let's move to the pre-processing steps. Then this is my literature review, which I am getting for this study. Now see the proposed system architecture. Here I am using the NCT-CRC data set, which is first apply the data pre-processing. After that, some feature selection by using RFE and some feature extraction using the efficient net B0. So these are the technique I am using over my the data set. After that, some data needs to split for the training and testing. Then transfer learning model is used for the classification, ensemble model for the prediction whether the person is having a cancer or not. Now see, let's see. This is the cancer data where I am giving the input to the pre-processing. Now here normalized pixel values, data augmentation, resizing, and one hot encode tissue labels. So these are the data augmentation over the images, that is rotation, flipping, and zooming. I'm applying on the cancer images, colonoscopy images. After that, it has to fetch to the feature extraction for the efficient net. Again, the data is split into the testing and the training purpose. These are the polyp identified in the images. In the transfer learning model, I am using the efficient net B0, ResNet 50, and finally the transfer learning model for the classification, which is used to identify the what kind of prediction risk identified by the person. Next, here the problem formulation. Now see here, these are the normal begin polyps, adenoma, and early stage CRC. These are the images I have to fit to my this model, and then RGB pixel value is generated. Here x equals to IR to the power h into 3. So This formula I am using where are the RGB colonoscopy images are used. Learning algorithm is used to identify whether the image or whether the person is having a cancer or not. After that, the efficient net B0 is used. Here I am giving the input to the this efficient net block. It is generated the output in the form of whether the image is having cancerous or not. Now, when we have to move for the efficient net B0, why I am using this efficient net B0? Because it is lightly weight algorithm. It gives the good accuracy. So here converted the input images into the grayscale to go through these are the steps to reach to the final output. After that, image processing, here I am using a colonoscopy images. It has to again resizes. Here the pixel normalization, rotation, flipping, zooming, that means the data augmentation needs to be performed. And finally, from the pixel normalization, it is identified the images having the cancer in which stage, whether it is 0 or whether it is 5 stages. So feature extraction is by using this feature extraction, pretend CNN network is uses. It has to generate the low level feature, mid level, and the high level features are used. Whenever we are using the data augmentation, our data is converted, that is image is converted into the binary pixel matrices. So here ones and zeros are data coming from that images. Now one means the polyps, that means the polyp is at which stage. Polyp is there identified in the images, and zero means the normal tissue. So from this data, our model is identified the cancerous patient, the images is cancerous or not. And performance matrix. So here we can measure accuracy, precision, recall. So finally, the accuracy achieved in my project is the 98%. So these are my training accuracy and loss graph. So here training accuracy by this is 98.6%. Loss is 1.23. And finally, the comparative study is that in this, the previous in 2023, the CNN technique is used by some author, which is having 95%, 95.6% accuracy. Next in 24, it is used by 96%, in 2025, 97%. And now my study, which is using the ensemble model, which is identified 98% of accuracy. So finally, this system is very useful to all our the globe, which are the most of the male person are affected with this colorectal cancer. And most important thing is whenever these cancer affected in the young generations. So this is a very huge problem to all over globe. So we need to control from this study. These are my references. Thank you.
Yes. Yeah. Rekha ma'am, thank you for this. Really good job. Have you completed a complete implementation of this one with all the things, or you are still working on it?
Sir, I'm working on this.
Okay. So most of them you have already predefined data set and you are working on that part only as of now, right?
Yes, sir.
Any future plans like getting the real-time data from the
Yes, sir. I have contacted with the cancer hospitals in our Nagpur. So they are giving me the real-time data, because very few patients are these cancers. This is actually common cancer, but no one having the that much curiosity, that, and no one is share
the
their.
problem is people are unaware of it
Yes,
most of the
sir.
time.
And
So
they are
that is the
not
main
sharing their things to the, that is because very common features. If we have a diarrhea, if we have some gas problem, stomach problem. So these are the common symptoms of this cancer also.
Yes,
So
yes.
everyone understand that, oh, this is a normal things. Why we go to the hospital and why we do the screening like that.
Yeah, exactly. Right. Okay. Good. Good presentation.
Okay.
Thank you.
Thank you, sir. Thank you.
I would like the next author, Potela Sunand, for the paper title Mapping Industrial Relations and Evaluating Employees' Perceptions Through Social Network Analysis. Sir, do we have you?
Hello,
Yes,
sir.
sir.
Good evening, sir.
Good evening, sir. Sir, you may share your screen.
Okay, sir.
Hello, Mr. Lakshman.
Sir, sir.
Yeah. You can share your screen.
Okay, sir. Are you visible to my screen, sir?
Not right now, sir. Visible now. You may start.
Okay, sir. Thank you, sir. Good evening, sir. Respected chairperson, honorable panel members. Today I am pleased to present my research topic, mapping industrial relations and evaluating employee perceptions through social network analysis. This study explores how formal and informal relationship among employees influence industrial relations, communication flow, trust, and overall organizational harmony. Content abstract introduction, study of area, industrial relations, social network analysis, and also conclusions. Abstract industrial relations uh, traditionally, using policies like industrial relations play a pivotal role in shaping employees' perceptions and enhancing overall organizational effectiveness, especially in dynamic sectors such as the pharmaceutical industry. It explores the effectiveness of various advanced analytical techniques in evaluating IR from the perspective of employees. This study it includes like the pharmaceutical sector, where coordination and compliance are critical. Misunderstanding and trust gaps can lead to conflict, dissatisfaction, and reduced productivity. Therefore, the study adopts social network analysis to uncover the hidden structure of workplace relationship using a data set comprising 30 employees from three different companies. Like the study evaluates key social network metrics, degree centrality, betweenness centrality, closeness centrality, and igniter centrality, and communication frequency per week. These indicators were synthesized into a comprehensive social network analysis score 0 to 10 for each employee to assess their influence and the connectedness within their organizational networks. The analysis detailed visualized in the heat map and comparative reveals significant intercompany differences. This research confirms these disparities through our asymmetric comparisons, supporting the conclusion that stronger, more centralized communication networks are linked to more effective industrial relations climates. The findings emphasize the role of communication centrality and frequency in shaping employee perceptions, enhancing collaboration, and ultimately driving organizational effectiveness. This research demonstrates social network analysis provides a valuable diagnostic tool for evaluating and improving industrial relation through the lens of employees, connectivity, and engagement. Industrial relations constitute the dynamic relationship between employers, employees, and their representatives, and the critical to ensuring harmony, productivity, and sustained organizational growth. In the highly competitive and regulation uh, driven environment of the pharmaceutical industry, effective industrial relations strategies not only foster employee satisfaction but significantly contribute to organizational effectiveness. Um, the main objective of this research to map industrial relations network within organization to analyze employee perception of fairness, trust, and communication. to identify key influencers like brokers and communication gaps using social network analysis. This diagram figures describes research that involves a combination of relations, data, and survey of employee perception to be examined in the form of social network analysis. It starts with the gathering and pre-treating of both sets of input data, such as the industrial relations, communication logs, and organizational charts, and the data of employee perception, concentrating on the trust, cooperation, and satisfaction. This data is the inputted into the central social network module, which does network analysis like measures such as certainty, density, and clicks, as well as perception analysis, sentiment analysis, topic modeling, and cluster analysis. Second, literature review systematic analysis on the proposed my study illustrate the analysis of social relations in the industrial process and the assessment of the perceptions of employees based on the social network analysis. Study has already attracted a lot of attention to organizational research, since it can be used to obtain more subtle information regarding informal relations, patterns of communication, and employee attitude. Emotional capabilities, current day, organizational process, and technological innovations are becoming the main factors that condition the modern environment of employment relations. The study focused on employees from major pharmaceutical companies, like located in North Coastal Andhra Pradesh, in especially Visakhapatnam and Srikakulam district in North Coastal area. These regions were chosen due to their significant contribution to the pharmaceutical sector, hosting numerous manufacturing units and research facilities. Like this approach enabled to visualize and quantity workplace relations. We apply to social network analysis metrics such as degree of centrality uh, between us, centrality to identify information brokers, closeness to centrality to understand communication efficiency. Like data collection means from the study area illustrate involved three primary methods: structured surveys, in-depth interviews, and secondary data analysis. The target population included employees at various hierarchical levels, such as production workers, supervisors, HR personnel, and trade unions representatives. This diverse representation ensured a comprehensive assessment of industrial relation within the sector. A sample size of number of employees, 30 employees, was selected, consisting of 200 surveys respondents and 100 interview participants. A stratified random sampling technique was used to ensure proportionate representation across different job roles and experience levels. The stratification of considered factors such as employment type, permanent or contractual or temporary, years of service, and department like production, quality control, and administration. The perspective of enhanced reliability and validity, the sampling strategy is based on a total sample of 300 respondent in survey of 100 respondents in interview, and is stratified using a random sampling strategy to obtain proportionate representation of the stratification factors, including but not limit to employment type, years of service, department, and job roles. This block diagram gives the scope and method of sampling in the study and the beginning points in the study area, which is the pharmaceutical companies in the major industrialist centers of Visakhapatnam.
Excuse me, sir. It's just a dental reminder that 9 minutes of the presentation are up.
Okay, sir. Social network analysis is a powerful analytical technique used to examine the patterns of relationship and communication among individuals within an organization. In this context of industrial relations and employee perception in the pharmaceutical industry of North Coastal Andhra Pradesh, enables researchers and managers to visualize and quantify how employees interact, share information, and influence each other. Network of connections between employees nodes and the relationship or communications among them. By analyzing these networks, social network identify key factors such as central connectors, brokers, and peripheral players, which helps understand informal influence, communication flow, and group cohesion. So after initializing a graph, the process splits the determining the important social network analysis values, degree centralities between centrality, closeness centrality, and network density. The calculation of all the metrics is preceded by step of printing or storing result. This improved logical flowchart means a Python enabled process to comparative social network analysis. It starts with the importation of the required libraries such as network, and the flowchart then outline various paths of data loading such as edge, a list, or adjacency matrices, various sources like CSV, Excel, which are then used in creative networks graphs. After initializing a graph, the process split determine the important social network values. Like employee from three categories, three companies of employees. Data set reveals clear patterns. Employee from company A generally show higher integration and influence in their communication networks, reflected in multiple high social network scores. The social network analysis map plots relationship that contribute to the overall industrial relations in a pharmaceutical environment. Various factors affected the core IR climate, or expressed nodes and links like training, compensation, work-life balance. This map is useful to outline structural programs. Conclusion: the profound social network analysis of industrial relations within the pharmaceutical industry shows that the relations within the workplace are not only dictated through the formal structure and policies, but are intensively influenced by informal networks and the perception of fairness by the employees. The difference that is regular as seen by the striking difference between what the management felt HR policy was fair 80%, or what employees thought 55, reflects a great level of trust and communication barriers that are unsupportive of harmony in the organization. The mapping also shows that the general climate of the industrial relations largely depends on the activity of the central actors such as informal leaders and union representatives. Thank you, sir.
Thank you, Mr. Sunan. Mr. Sunan, Lakshman Sunan,
Sir,
what is the actual essence of your paper?
my paper is employee perceptions to social network analysis, sir.
Means by gathering that info and all, what you want to propose or present in your paper? What's the thing that you want to convey?
Canonical correlation analysis and sentiment analysis using natural language processing, and use it to like Delphi techniques and metric analysis, including like an employee perception, including correlation to like social network analysis, sir.
It's okay. Anyhow, thank you.
Okay,
Right.
sir. Thank you.
I think you can better present in better preparation. Right. Thank you.
Thank you, sir.
We would be calling the next author, Srinivas Desai, for the paper title Performance Analysis of 5G NR Sidelink for Vehicle to Vehicle Communication.
Yes, sir.
Yes. Sir, you may start your screen.
Okay. Just a minute. Is it visible, sir?
Yes, sir, you may start.
1 second. Our problem statement is performance analysis of 5G NR Sidelink for vehicle to vehicle communication. We consider these motivations. In the 5G V2X, reliable and low latency is essential for road safety and coordinated movement. And the performance of 5G NR Sidelink depends on effective resource allocation. Uh, wait. Uh, the inefficient allocation leads to the collisions or increased latency and a reduced throughput, required optimization for reliable communication. So means, overall this, the motivation is in the 5G V2X, low latency and the high throughput is very important. So these are the various types of communications: V2V, V2I, V2P, V2N. So we worked on V2V communication. The objectives are analyze the performance of 5G NR sidelink communication for vehicle-to-vehicle scenarios using MAC layer-based scheduling. Analyze the effect of resource allocation, and we use SPS mechanism to maintain reliable V2V communication, and the evaluate throughput and latency based on the different vehicle speeds and the different inter-vehicle distances. There are mainly two types of communication modes. The one is direct sidelink mode. We used it in our project. The other one is network assisted mode. The need for PCFi interface means we used PCFi interface because it eliminates the GNB. Means vehicle communicates directly with the another vehicle instead of the vehicle first communicate with the GNB and the GNB transmit its messages to vehicle. So instead of that wasting of resources and time, in PCFi vehicle directly communicate with another vehicle. So to this communications are reliable and the latency is reduces, and it gives a very good throughput. We consider this six paper. The overall summary of this papers are the many papers are not working on the PCFi interface. Means many are used through existing models are in V2X, V2V are used like a GNB. In that paper, their latency and throughput is not good. It is our flowchart. The first is we initialize the system and allocates the CAM resources parameters. In this simulation cycle, vehicles are continuously updates their positions, and the CAM resources are continuously reassignments, and then performance evaluations. Uh, these are the input parameters we consider it, and we used semi-persistent scheduling type, and the communication interface is PC5.
We consider vehicle speed 20, 25, 30 mph, and the inter-vehicle distances are 50 meter, 100 meter, 150 meter. And the carrier frequency bandwidth are all standard 3 GPP values. In the Mac layer, there are many functionalities. We mainly worked on resource allocation, scheduling, and HARC processes. These are all Mac layer functionalities. In the resource allocation, the Mac layer handles it all, allocate the resources to users. That's it. And the scheduling is means which user gets how much resources, and when and which resources a vehicle uses to transmit messages, ensuring timely delivery. And it is used to avoid the collision. The HARC process is used to detect the error and retransmit the error packets. So these are results of, we mainly consider latency and throughput. We consider three vehicles with different speeds and three different inter-vehicle distances. In this output, the vehicle with a higher speed has a high latency. The overall maintaining moderate speed and sufficient spacing improves communication responsiveness, supporting safe and more coordinated V2V operations. The overall, the when a vehicle is close to the RAC, means GNB, and vehicle speed is slower to the other, it has a better latency, low latency, and it is throughput. The vehicle with a high speed is bit bit more low throughput, uh, other than the slower vehicles. The vehicle with higher speed throughput drops significantly due to the rapid changes in the speeds and the channel quality. In the conclusion part, the 5G NR V2X shows better reliability, higher throughput, and lower latency when a vehicle move to lower speeds and maintain closer spacing. The results confirm that 5G NR V2X can support safe, coordinated, and efficient connected and autonomous driving in real-world traffic scenarios. Uh, in the picture works, extend the simulation to larger vehicle networking and include realistic channel conditions and traffic pattern. And we consider this paper as a references. Thank you, sir.
Yeah, Srinivas,
Yes, sir.
have you done any simulation or a real-time work for this?
No, sir. For now, we done this in only MATLAB.
MATLAB simulation, right?
Yes, sir. It is the now we extend this project in like a real time, using real time data set, like in, and real time simulator like NH3.
Okay.
For now, we only
Okay,
done
right.
MATLAB.
Okay, right, Srinivas. Thank you.
Thank you, sir.
Now I would like to call the next author, Srishti, for the paper title Performance Analysis of Machine Learning Models in Agricultural Disease Prediction.
Yes, I'll share my screen.
Yes, sure.
Is it visible?
Yes, it is.
Yes.
Good afternoon, everyone. My name is Shrishti, and I'm a computer science undergraduate at Indira Gandhi Delhi Technical University. And this research was conducted under the guidance of Ms. Khyati Alawat. Today, I'll be presenting our work titled Performance Analysis of Machine Learning Models in Agricultural Disease Prediction. So, before I discuss the technical part, I want to start with a simple introduction. Agriculture is still the backbone of our country. Around 65% of India's population depends on it. One major challenge that farmers face every year is crop disease, which can reduce yield by almost 30 to 35%. Traditional manual methods for disease identification is slow, time consuming, and often inaccurate, which highlights the need for automated solution. This is where machine learning becomes useful. In this work, we analyzed 8 classical machine learning models to predict diseases in tomato and maize leaves using image based dataset. Moving on to the problem statement. So, based on the introduction, the problem statement becomes quite straightforward. The key challenge addressed in this work is to develop an automated and reliable machine learning based system for accurate disease detection on both balanced tomato and imbalanced corn datasets. Now, let's take a look at literature review. Before developing our method, we reviewed multiple studies on plant disease detection. Some studies apply classical ML methods, other studies use environmental data like soil parameters or weather variables to predict crop yield. Many papers highlight the strength of deep learning, especially CNNs. These CNN architectures perform extremely well, but they require high computational power, which may not be suitable for real time deployment. These gaps motivated us to design a pipeline that focuses only on classical ML. Now, coming to the research methodology, let's take a quick look at the workflow first. Our overall workflow begins with image acquisition, followed by data preprocessing. Next, we perform feature extraction, apply augmentation and smooth for balancing, and then use PCA or select key best for dimensionality reduction. Finally, we train and evaluate ML models and compare the results. I'll explain each of these steps in detail in the next slides. For data preparation, we use two publicly available datasets, the balanced tomato leaf dataset and the imbalanced corn leaf dataset. We split both datasets into 80% training and 20% testing. For data preprocessing, we resized all images to 224 by 224 pixels for uniformity. For feature extraction, we converted images to grayscale. For augmentation, RG images were retained, and we also removed noise and applied normalization. Now, for feature extraction, we used HOG, LPP, heraldic features, color histogram, HSV, color moments, and flattening. We experimented with different feature combinations and selected the ones that produce the best accuracy for each model. For data balancing, since the corn dataset was imbalanced, we followed a two-step balancing strategy. First, we applied data augmentation to increase visual diversity, and then smooth was applied only where needed to further balance the minority classes because applying smooth alone was leading to overfitting. For the tomato dataset, which was already balanced, data augmentation was used only to improve generalization and robustness. For dimensionality reduction, we used PCA and select K best. These techniques reduce feature redundancy and minimized overfitting. Moving on to the training and testing part, we trained all 8 ML models: logistic regression, SVM, KNN, decision tree, random forest, naive Bayes, Bayesian network, and K-means. We used grid search CV for hyperparameter tuning and cross validation to ensure stable and reliable results. For evaluation, we use matrices such as accuracy, precision, recall, F1 score, and OC. These matrices help us understand not only the overall performance but also how well the models perform on individual classes. Now, coming to the results, SVM performed well on both the datasets, achieving 90.38% accuracy on the balanced tomato dataset and 86.52% accuracy on the imbalanced corn dataset, with strong precision, recall, F1 score, and an high OG of 96.85%. Random Forest also performed strongly on the tomato dataset with 90.10% accuracy. One observation that we observed during our analysis was that classical ML models struggle due to limited computation power and their dependence on manual features. Also, they struggle due to high dimensional data. This slide shows the class-wise prediction performance of different models on both datasets. While most models perform consistently on the balanced tomato dataset, the unbalanced maize dataset clearly highlights SVM's stronger class-wise stability compared to other models. Lastly, I want to discuss the future work and conclusion. In the future, this work can be extended using CNNs for better image understanding. It can also be deployed as mobile or web app for real-time disease detection with multilingual advantage. And it can also be integrated with IoT sensors and drones for large-scale monitoring, which can be supported by explainable AI techniques like SHAP or LIME to improve transparency and farmers' trust. To conclude, this study presents a complete machine learning pipeline using classical models for tomato and maize leaf disease detection. 8 ML models were trained and evaluated for both the datasets. SVM consistently showed the best performance across both the datasets. Overall, this work shows that classical ML, when optimized properly, can offer accurate, lightweight, and scalable solutions, especially useful in areas where deep learning might be too computationally expensive. These are the references used in this study. Thank you for your time and attention, and I'd be glad to answer any questions that you may have.
Do you have any questions for the presenter? Thank you, Srishti, for presenting. I would like to conclude it with closing remarks. One second. I sincerely thank all the authors for their excellent presentations and contributions in this session, and all our participants for being a part of this international conference. I hope this session was informative enough. We, on behalf of the whole team, thank you for the support during this 10th version and all the previous 9 versions of the conference. We'll be very happy to have you in the 11th version in 2026. All the presenters would be getting their digital certificates through email within 2 working days. The publications will be live within 7 to 8 months. Accordingly, kindly cooperate with the team of ICCTS. I also thank our session chair, Mr. Ravi Kumar. This is the token of appreciation from the conference ICCTS. Sir, any closing remarks you would like to give? I guess there are some technical issues. So I request everyone to kindly switch on their videos as I have to click a virtual photo. Thank you very much.